This is the fifth and final part to our sequences and series chapter. And here we have a sigma expression. Here is equal to this. What does this mean? Sigma means we're doing a summation. So a plussing with terms of substitution value beginning at 3, right? Running from 3. Now, because it's a plus, it means however many terms are involved here in this series, it needs to add up to this, which is the right-hand side. So this whole side here is actually the answer. So I always like to do the first 3 terms, term 1, term 2, and term 3. Iterations starting with the corresponding p-values. So for term 1, you're going to write this 4p minus 1 times n, where p's value is 3, our initial value of substitution. So that is 4 times 3 minus 1 times n. 4 by 3 is 12, minus 1 is 11 times n. So that is equal to 11n. For our term 2, it's going to be the next iteration, which is the p consecutively after that. So it's going to be, the p value is 1 above 3, so 4 less 1 times n. 16 less 1 is 15, so that's 15n. And then you're welcome to do the next one just to establish what type, is it arithmetic or geometric. The next value is going to follow from 4, so that's 5. 20 less 1 is 19. 19 times n, 19n. So we're sitting with 11n plus 15n plus 19n, and so on, continuing with that structure n amount of times. Clearly, you can see to go from 11n to 15n, you're adding 4n. To go from 15n to 19n, you're adding 4n. It's not just adding 4, because 15, let's just take it with 15n plus 4. That is not like terms. Here's n, here's just a constant. So it has to be n. 15, let's say, notches plus 4 notches. 15 plus 4 yields 19, of that nature, like terms. That's now perfect because we've established that this is going to be an arithmetic series to do SN. Filling everything in. With this n squared distributed to n plus 9, that's the answer we're working towards. So keep that in mind. All of these parameters we figured out, we're going to plug in. So n, we don't know what n is as of yet. So I'm just going to maintain it from this point. N over 2. Our a value, the first term is 11n. Plus our difference is 4n. Now just expanding this. So that's n over 2. 2 by 11n is 22n. Distributing here, that's going to give me 4n squared minus 4n. So identifying some like terms over here. So n over 2. Here is my 4n squared. That's the only one of its nature. 22n minus 4n is equal to 18n. And now we're going to distribute this. Okay. So n over 2 times 4n squared is going to equal, so 4 divided by 2 is 2, and then we have the n squared being multiplied with n, so that's n raised to the power of 3, and then we're going to do the same process here. 18 divided by 2 is 9, and then we have n by n, which is n squared. All I'm going to do now is remove a common factor, n squared out. N squared is actually better because we have the common factor is the biggest number you can pull out. That's a n squared. So pulling out n squared, that leaves me with 2n. And when I pull n squared out of here, it leaves me with 9. It is originated at the left-hand side. And it's also equal to the right-hand side value, which is that as required. The sixth term of an arithmetic series is 18, and the sum of the first 8 terms is 168. Determine the series. So they basically want you to list out the series. So using this information, sixth term is 18. So T6 is equal to 18. And then the sum of the first 8 terms is 168. So that's the sum to 8 is equal to 168. And we're working with arithmetic series, so we can expand this using the SN formula. SN is equal to now SN, we are given it here, so we can actually plug in this value of 168 in the place of n when our n value is 8. The reason we want to do this is so we can figure out what is A and perhaps D, because A and D are important in establishing what a sequence or a series is. So I have the 168, the 8 over 2. 2A, I don't know A. D, I don't know D. And then I have 8 minus 1. That's 4. 2A plus 8 less 1 is 7. Distribute with D, 7D. Okay. All right. Now, perhaps we can try to isolate one of the variables because this is likely going to be a simultaneous equation. So I'm going to divide both sides by 4, 42, to A plus 7D, and then I'm going to get the A expression alone. So 2A is equal to 42 minus this 7D, and then to get A alone, it will be 42 less 7D all divided by the coefficient. Okay, I'm just doing that so I have A in terms of D. Now I'm going to expand this one in a similar way. This is using TN, general structure format. Tn is equal to A plus D, n minus 1. Tn's value is 18. I don't know A, don't know D. N's value is 6. So it has to correspond. Okay, so we've got A plus 6 less 1 is 5. That's 5D. And I'm going to get A alone. So to have A alone, it's going to be 18 less the 5D. Now check that out, guys. We have an expression in terms of A and another expression in terms of A. Simultaneous equation says we can now equate them. So I'm going to take equation number 1 and equate it to equation number 2. So I'm going to write 42 minus 7D over 2 is equal to expression number 2, which is 18 minus 5D. Okay, I'm going to get rid of the fraction structure over here by multiplying both sides by 2. So that gets rid of the fraction and then it distributes here. Okay, so 18 times the 2 is 36. Minus 5D times 2 is minus 10D. And now we can group our like terms together. So I'm going to have the minus 7D. I'll bring the 10D to join it. So plus 10D and then 36 minus the 42. 10 minus 7 is 3D. And then 36 minus 42 is equal to -6. And clearly from this, division by 3, D is equal to -2. Look at that, guys. We got the first parameter. All we have to do now is find A. So we can plug this into either one of the expressions. So we used A to find D, and now we'll use D to get the numerical value of A. So I'm going to put it back into the one that looks simplest, which is going to be this one. So therefore, I'm going to say A can be obtained by taking 18 minus 5D, where D is minus 2. Okay, so A is equal to 18. This 5 multiplied by -2, that's -10. But the negative in front negates it. So that turns it into +10. Minus times minus is plus. 5 by 2 is 10. So the value of A is 28. And that's all we need. Remember what the question said? It said here to determine the series of the first 8 that yielded 168. So I need to figure out the 8 terms. Starting at the first term, it's 28. Applying the difference, which is a subtraction of 2, 26 plus 24 plus 22 plus 20 plus 18 plus 16. Let's see, 1, 2, 3, 4, 5, 6, 7, and then plus 14. How did I know to do this? Because we're starting at 28, and every time the next term is 2 less than that one. Starting at A's value 28, and then each term is going to be 2 less than the previous one. I'm just going to show you that the summation of this expression I have for the series, let's see if those 8 terms actually do add up to 168 as per the question. I've inputted all of the 8 terms, and you can clearly see the value is equal to 168, and that was given in the question. 3xy minus 27, where the first 3 terms form part of an arithmetic sequence, while the last 3 form part of a geometric sequence. Determine the value of x and y that can make this possible. So for the arithmetic sequence, we're going to use a particular Tn. I'm just going to write that for our revision purposes. And then for the geometric, the Tn is equal to a times r n minus 1. What sets these two aside or apart from each other? Arithmetic has a difference, while geometric has a ratio. So this could be x minus 3, as well as y minus x. Remember, differences are constant, so you can equate them. Doing it like this constructs an equation and makes use of all 3 terms, while the ratio is equal to the quotient of a term with the term before. So that would be minus 27 divided by the term before that, which is y. Another one we can equate that to is the y over the x. So what we have done is formed equation 1 and equation 2, which we can use in simultaneous equations. I'm going to try to isolate, let's say, x. So over here, if I get x alone, I'm going to do so by inversion. So that could be x over y is equal to y over negative 27. If you flip the one side, you can flip the other side. And then I'm going to times by y. So that would yield y squared over minus 27 is equal to x. Okay, all following there. So by the process of inversion and multiplication, I've isolated x. And to isolate x here, I'm going to carry the minus x over, which is 2x. And then here is y plus 3. And then to make x the subject, you'll simply divide by coefficient 2. Here's an expression for x. Here's an expression for x. You can equate them now. Therefore, the first x expression, it's y plus 3 over 2. That is equal to the second x expression, y squared over negative 27. Now that we have that, we can proceed to solve the numerical value of y. I like to do the cross multiplication. So I'm going to multiply those two and these two. So minus 27, distributing here, it's minus 27y. And then minus 27 times positive 3, negative 81. And that will equal y squared times 2. That's 2y squared. And you can clearly see this yields a trinomial. So we got 2y squared plus 27y plus 81 is equal to 0. And now we can find y. I'm going to use the quadratic formula to obtain this. So therefore, the first solution when plugging in the plus, I get y is equal to 9 over 2. And then when I plug in the minus, I get negative 9. Y is equal to negative 9. So now that we've used the x formulas to find the respective y's, let's plug them back. Okay, so you can choose which one. I'm going to stick with this one just to avoid any errors with squares. So if the formula was x is equal to y plus 3 over 2, let's plug it with each respective one. So the first one is going to be, the y value is negative 9 over 2 plus 3 over 2. That yields negative 3 over 4. And then when we plug in the other one, which is negative 9, that yields minus 3. So I'm just going to list them. X is equal to negative 3 on 4 when y is equal to negative 9 on 2. And then the other solution is equal to x negative 3 while y is negative 9. Both of those work to ensure that it is arithmetic as well as geometric. Given this series, for which values of k will the series converge? Now, for series to converge, it means we're working with a geometric series and using some of our understanding of sum to infinity, okay? So here, this is basically a geometric series, and what's important here is a ratio. So to establish the ratio, it is term 2 divided by term 1. So that means you're going to take this and divide it by this. You're welcome to show the expansion of it. I'm going to just do it in my head. Using these numbers in front, 10 divided by 5 is 2. And then taking this bracket, which is identical to this, something divided by itself. So it looks kind of like a squared divided by a is equal to a, right? Because 2 less invisible 1. So it's the same thing here. So it's going to be 1 minus k over 3. So that is the constant ratio. So to ask for which values does it converge, convergence happens within the bounds where r is less than 1 but greater than negative 1. So here is your r value. So you're going to plug it in to 1 minus k over 3 less than 1 greater than negative 1, and we're going to solve it using our knowledge from it. To get rid of this 2 in front, I'm going to get rid of this multiplication doing division. So minus 1 divided by 2 is minus a half, and then 1 divided by 2 is equal to a half. Now to get rid of the 3, I'm going to multiply because to get rid of division. So I'm just going to carry it over here. Obviously, you will have more space when you do it in a test and so on. So that is going to be 3 over negative 2 and 3 over 2 because 3 becomes part of the numerator. And then to isolate this minus k, so that's going to be 5 on minus 2 and 1 over 2. And then just to get k in the right structure, I'm going to divide through by the negative. And remember, students, this means that the inequality is going to flip. So to get rid of this minus, it's now positive 5 on 2. And then to get rid here, it's minus 1 on 2. So that's the answer. That are the values for which k will converge. To figure out term 10 in terms of k, we follow this trajectory. So you're doubling it, right? If you just look, so 5, 10, 20. So to go to term 10 here, it's going to be a, or, and then n minus 1. So that's 5 multiplied by 2 raised to the power of 9. 2,560. And then what you can see is with the bracketed term, they are repeats and the exponent value is the same as the term number. So therefore, term 10 would look like this. It is this number in front, 2,560. The bracket that's in every term, 1 minus k over 3, raised to the number of the term that it is raised to the 10. And that's the answer. And this concludes part 5 of our sequences and series chapter, our first topic covered for matric maths. Please do drop a like and subscribe. Do share this with your friends, and we'll see you in the next chapter. Thank you so much.